Said you were the moderator?
Mm-hmm.
Could you let me know when my start time is?
I think it's now.
Oh, it's now. Okay. All right. Well, several people I was hoping would be in the room by now are not here yet, so I will proceed anyway. This particular session, thank you everyone for coming. I've done this session in various forms and in various places, and I keep refining it as technology shifts and changes. And I'm trying to both tell you about what's going on in technology now, what the current thing is, and turn around and make it practical to what you really need in your jobs. It's real easy to ignore technology changes for long periods of time when things work, and then suddenly you take a look and go, oh wow, we can do all of that so much cheaper if we just had these tools. We can prevent these problems if we had those tools or the other tools. And yeah, hey, Dave and Aldo, or Dave and Kai, Aldo just went looking for you guys, so now he's the one out.
Okay.
Okay, so anyway, this is Scada, open source, and the Internet of Things. Who has already heard the term Internet of Things before? About half the room? Okay, thank you. Internet of Things, I'll get there. As far as who I am, I now work for Intelligent Automation Alerts and Analytics. You can look me up on Wikipedia if you have interest in any of my background and so forth. I'm going to go ahead and learn how to use this. First time I've ever used a clicker, so I'm new to technology sometimes myself. What are the parameters of this particular session? What can you expect? I'm about to cover years and years of material that's technical and technology related in a very short period of time. We have 2 hours together, and I anticipate that I'm going to get all of you involved in the conversation, regardless of what your level is. But we're going to wait for that conversation till about the last half hour. And the majority of the benefit in a group like this often comes from someone else in the group that you wouldn't have spoken to if the circumstance hadn't arisen. And I'm totally aware of that. So what I'm trying to do is set a stage and be in a situation where I'd really like you to take notes. Not because I'm all high and mighty and think you need to take the information home with you because I know more than you do, but rather because if you are a beginner, I'm going to try to do it in a way that does not leave you behind, and afterwards, we welcome your questions. If you have advanced knowledge, there may be people in here more advanced than I am, for all I know. And if there are, your input is welcome. Even if you're a competitor, maybe even especially if you're a competitor. Because I really believe it's about growing the pie and not worrying about your slice. If you take care of your slice and you help everybody grow the pie, your slice will grow too. That's always been my experience. That's what I've enjoyed about the Linux business and the open source space. It's about cooperation long before it is competition. Yes?
A rising tide floats all boats.
It absolutely does. Thank you very much. Good point. So this is for CEUs. Well, part of knowledge is who is everybody out there doing what. There's so many companies out there that you can't possibly know them all anymore. It seems like every week there's somebody new popping up in Internet of Things. That's the new hot area. But I'd like to come more to ground and be practical regarding what we need, and whomever is here, whatever they have to offer is absolutely welcome. So please, think of questions you want to ask, and in the final discussion, also be prepared to give any input you think of. And Dave, just so you know, I've got the items you asked for queued up on separate tabs. So if you let me guide you, each of the starts is there, and then you're going to need to do some of the work from there. Okay. But then hold those till the end, because I'm going to really get on a roll. And if we redirect, I won't get the material covered, and then we won't have the time at the end when we can really do the powwow. And I really wanted to get to the powwow. So, SCADA. How many of you know what SCADA means? How many have used SCADA systems? Oh, wow. Good crowd. SCADA stands for Supervisory Control and Data Acquisition. It's an acronym. Doesn't sound like much until you get into what is this anyway. It is about sensors and devices. Because we're going to go ahead and let you take care of that. Anybody else could silence your phones? That would be wonderful. It's about interacting with the real world. Computers, microcomputers, back, what, 20, 30, even 40 years ago, people are going, why will anybody ever need a computer? What's a computer good for? Well, no, that's the 60s and 70s. But there's older people at that time that were asking that question too. Well, the next thing that happened is with computers, they're levers for the mind. That's really what it is. It's a lever for the mind. Computers don't interact with the world unless you do something special. You are an I/O peripheral to your own computer. That's what SCADA, Internet of Things, looks to change. Let the computer interact to enact the story you want your real world to follow, and it sees to it that that happens. So to do that, it's got to have sensors and various kinds of devices that can detect various things, and that needs, those items need to not analyze, but detect the specific states, and then make sure that data is available to whatever the brain that collects the data, which may talk to more brains, and you may have an entire network of brains, and it can tie into something called the cloud. We'll go into that later. In order to do that, one of the traditional brains has been a PLC. A PLC is called a programmable logic controller. All of these techie terms you hear, they're just acronyms for real words. HMI, that's a human-machine interface. Think screen and keyboard usually. Could include mouse, could include all sorts of other stuff. Could include a Star Trek hologram if you want. We just don't happen to have those yet. Well, at least not for the average person. Now the PLC and the HMI are, in this form, devices that let, with the HMI, you can program or control the PC. Now typically, PLC programs are written using Windows software on a computer to do what you want it to do, and then downloaded to the PLC, which is then supposed to run it. And if there's a problem, you've got to fix it on the computer, and you've got this kind of back and forth process that you've got to do in the typical PLC world. That's even true today in the maker type PLCs like Arduinos and Raspberry Pi. Actually not the Raspberry Pi so much, but the Arduino for sure. Then you have various kinds of communications and layers of communications. And within a communication channel, there's lots of different protocols. There's the ones that just let the two devices talk to each other. Probably the simplest thing is, in a computer, you've got a byte that turns on, a bit that turns on and off. And you care whether the switch is on, a thick light switch, okay? You turn the switch up, the light's on. You turn the switch down, the light's off. That's a bit inside a computer. What makes computers make sense of these things is there's so many billions and billions of bytes in there, therefore there's lots of combinations of bytes that can be done. So bits that can be done, which then in sets of 8 becomes bytes, or in various sizes as words. In a computer, typically now 64 bits is a word. And you use that to encode information. That's all that's about. I keep missing the button here. It looks like an off button. So you then use it. You could then in a sensor, let's say a 4 to 20 milliamp sensor. You end up having a device that senses maybe pressure. Okay, and the pressure range could be from 0 to say 100. And your average system pressure may be in the 40s or 50s. So the way that works is the 4 to 20 milliamp, 0 to 4 milliamps means that your circuit works. The device is there and it's being seen. Above 4 milliamps, you end up having where the data is. You may notice from 4 to 20 is what? 16? 16 is 2 bytes. A byte is 8 bits. So it's the same computer logic used in the old analog circuits with the 4 to 20s that we're using now. We're just using it in a more sophisticated way now. If you were at 50 pounds of pressure on that 100 pound sensor, what would the reading be on the 4 to 20 milliamp device? You're almost right. 8 plus 4. Because you got to have the 4 that tells you the circuit's working. So it's 12. Good shot though. Okay? So there's layers of communication. That's probably the most fundamental layer of communication. If you have the on-off switch, that can be tracked as it's on or it's off. Simplest. Next most simple is like the 4 to 20, which takes an analog and encodes it into computer talk. That's all it was computer talk. And then when you go to Ethernet or RS-485 or protocols, basically that ends up being the communications that allows the PLC to talk to its sensors and devices so you can display on the HMI. Okay? Now, then if you want to turn it into a SCADA system, the HMI becomes not a local display like that, but rather a computer device of some sort. Okay? So, traditionally, the SCADA systems, Allen Bradley, Siemens, Johnson Control, the list goes on and on of who they could be, they've used Microsoft Windows. Typically XP. Well, Microsoft just dropped support for XP, so now everybody's being forced to do what? Maybe they'll go to Windows 10. Or maybe they'll adopt Linux, because with Linux, there's nobody can ever pull the plug on the support. They decide when to stop supporting it, or when to move to a newer version. They don't have Microsoft controlling them. So, SCADA systems typically are XP, maybe they're Unix, or maybe they're something else. There's various real-time operating systems available. There's still some DOS systems. There's some that are directly and natively what the manufacturer figured it ought to be. But those cannot keep up. You've got to keep those systems off the internet. Unless you have some way of firewalling, because they were never designed for security. Every day you hear about another hack. The latest big one is the Panama Papers. Who's heard about the Panama Papers? Are the people who are trying to run things getting embarrassed at what people are finding out that they're doing? Not surprised. They weren't paying enough attention to their security. In fact, they probably ought to be doing it first place, at least the way it looks. I don't know about that. That's not my call. What is my call is when I'm helping you with your system, I've always got to keep an eye on security issues. Typically with a SCADA system, that means keep it separated from the internet. There is something called a data diode that only allows one-way flow of the data. Like, for instance, let's say we're running a nuclear plant with a complex Allen-Bradley system, and we have our best guy is in Hawaii, and we've got a problem, nobody's figuring it out. With a data diode, the guy in Hawaii can, as long as he's got it connected to the internet via the computer, the guy in Hawaii can take a look at what's going on, but you don't dare let him control it, because if he could control it, somebody else potentially could hack and control it. So what he's got to do is have somebody who is junior to him, at least in that arena, back at the site. They talk by phone, and the other human deals with the input and control issue while he is able to see what's going on. That's basically what Scada is best at this point. Scada is about being able to see everything you can't spend the time with yourself. You can't necessarily afford a person sitting there moving the valve so the tank stays or the pressure stays at the right level. So you've automated with PLCs the valves, which are analog, according to pressure, flow, or some other parameter. And I'm using specifically water examples here because you guys are water people. In fact, electricity can be seen in terms of water. For those of you that water makes sense and electricity doesn't, there's some analogies you can learn where suddenly electricity starts to make sense too. It's really useful. I learned that in after engineering school, not in engineering school. They didn't think to tell me something that practical. So one of the issues with PLCs is you tend to need specialized labor. The specialized labor has to know how to program these PLCs because the PLC world is in the process of moving from old style computing to new style computing. Old style computing, you're still dealing with the processors and the interfaces and so forth, all very directly. And each vendor tends to be an island. If you have this from that vendor, then this and this and this and this have to be bought from that vendor too. That's been a concept that industry has used to, I am gonna own this area. I am gonna be the vendor that's the king of this space. Well, that is getting dated now. As we get into systems that have to interoperate with one another, the vendors are learning. They've got to band together and build the pie, at least in terms of letting the systems communicate with one another, so you get your choice of the devices you want. You pick the best device for this, the best device for this, the best device for this, and the brain darn well better be able to talk to them all. So the old way, each vendor has been an island. And they tend to be, for above reasons and more, rather expensive to install and maintain. Now, something I didn't put on the slide that does matter. They also have been built to industrial strength standards that tend to be durable. They've been built to last 20, 30, 40, 50 years. And you hope the vendor is still around to give you the part you need. And even if they are, the majority of the time what they'll do is they'll say, no, you need to buy our newer system, which is compatible, and by the way, this is going to be the bill. And now you're finding yourself replacing a large part, if not your entire system. I consider that from our end, as users, totally unacceptable. Because it's more of the it's more of the forcing you to be on our deserted island. So that's basically my assessment of today's SCADA. Now that's not to say all of the vendors aren't starting to move forward. They all have been, for instance, starting to push you guys towards Ethernet, right? Who's not heard from a vendor, oh, you need to Ethernet that? The interesting thing is they're only just seem to be waking up to Ethernet. In the computer world, that was a technology we invented in the 70s. That's what is the layers of communication on the pipe, on Ethernet, are also the layers of communication on the internet. And basically the idea is you make things that make sense in themselves and then you reuse them. You're building Lego blocks. So users can assemble the Lego set however they want. There's two kinds of Lego sets you can buy your child. You can buy them the fancy robot with the brain, and that Lego set can never be anything but that, or a pile of bricks. Or you can buy them a generic set where they can really use their imagination and build whatever they want. Or you can buy them a bunch of those specialized ones to get them started, and now you've got enough crossover stuff that they can build some really weird stuff. But you never know what they're going to come up with, and some of it's pretty darn cool. And that's the same way with open source. So, open source. What is open source? Open source is the ingredients plus the recipe. It's that simple. That's all it really is. Now, granted, there is a legal definition since the word open source in that form has been trademarked. And those of us who were there at the time did that on purpose, so that when somebody says open source, they mean more than the source is available. They also mean that you are being transferred rights to do what you need to do within parameters, and that depends on which license they decided they will give you their code with. Okay? There's licenses that says you can do anything you want with it, but if you ever give it to somebody else, you need to give it to the world. The benefit of that is if the world is interested in it, they make advances that you can have back. And now you're pulling forward together without a vendor. Some responsibility, maybe, but also power. Whoops, not ready for that one. So, what does open source apply to? Well, on one level, if you've got those PLCs that we were talking about earlier, and they're talking to your sensors, and they realize that the tank should never get fuller than this, and it turns the well pump off, and the tank should never get emptier than this, and it turns the well pump on, or whatever else it does, there is some code in there. In the case of PLCs, it's typically ladder logic. That's the traditional code that's been used. The ladder logic is basically a flow diagram. You can do most anything in ladder logic, but it is not as flexible as today's computer languages. So now what's happening at most places is they're talking about how they can run C++ or their own language. Well, believe it or not, a fair amount of the ladder logic that's been sold for the last number of years was actually written in C++ in the first place. The ladder logic was an application on top of the C++. What they're doing is they're now giving you more power by giving you access to what that was written in, so you can now extend it. Instead of having to run the fixed loop, you can have multiple brains working together in a consistent way that you don't have to redesign from scratch. So open source applies to ladder logic in this way. If a vendor builds a system for you, okay, virtually none of the companies have the tech staff to do a full automation of let's take a water plant as an example, okay? You have a water plant, you want to do a full automation of it. You decide you want to use a Siemens PLC. I need to start mentioning different brand names here. You decide you want to do a Siemens PLC. You also hire a guy that has skills with Siemens, or maybe a student that has played with one who you figure can learn. There's quite a cost to that, but it could be a good deal too. When that person leaves, when the system is working, assuming it works, and the person leaves, if you don't have the source code to the ladder logic that's running, you can never change that system. Don't ever let them walk out the door without you having a USB stick that contains the source code for what's running on that PLC. At the most fundamental level, that's the point of it. So having source code facilitates collaboration between vendors and customers. It protects you when vendors fail or stop servicing. That applies to security breaches, that applies to upgrades. That gives you power to determine your own way if you accept the responsibility. And accepting responsibility can be as simple as having somebody on staff that knows and replacing them if you know they're going to leave. You know, making sure they have the skills. It doesn't mean you personally have to do everything. Open source has already won the world.
Mhm.
If you use Google, use open source. If you use Facebook, use open source. Granted, they're not giving you the source, but you're using the results of their having been able to build on the libraries of open source that thousands and thousands that are not being paid did in the first place. Apple was going to die if they had not adopted FreeBSD. The reason they didn't adopt Linux is because they would have had to put the Linux logo on their machine, and that was unacceptable. They have to have people believe that they've done everything that's there. What they did is about 5% of the software that's there, the user interface, and ported that on top of, in effect, Linux or FreeBSD. Samsung, these fancy devices, the iPad, the Samsung phones, the Motorola phones, pretty much doesn't matter. The smartphones are all based on the same technology that's been developed in the computer world all this time. Even Microsoft now has announced that they're opening their source because now they have understood they're finally beaten. That was a mission I set out on in the early 90s, actually a little before that, when they started feeling their oats and stopped being so easy to work with, that Microsoft cannot own the world's data. People need to be able to own their own data. People need to be able to control their own destinies. At least that's my opinion. Anybody else agree?
Mhm.
Thank you. Now, Linux is but one example. Linux is currently the king of the open source space. Why? Because anybody can use it for anything. Because Linus Torvalds was the right guy. He doesn't care. He just wants Linux to be technically as good as it can be. And the Linux Foundation, which I helped put together, ended up establishing the Linux trademark after he said that, no, we don't want a trademark because we want everybody to use it. We found out, no, you can't do that, because then the abuser registered the trademark. And net result was we had to do a lawsuit to get the trademark back and define it as everyone can use it, unless they're an abuser. So anyway, Linus is now paid by the Linux Foundation because of the fact that we managed to pull that Linux trademark back. And the Linux Foundation is known as the entity that is the fair umbrella for anybody that has a project that could impact the world to go to, and they will help you manage, promote, and get a audience for the project. They are the kind of the foremost build the pie first company. Excuse me, non-profit association. Gotta keep my stuff straight. What kind of software is available for Linux? Now, LibreOffice is largely Microsoft Office compatible, not completely. What else can anyone think of that might be available for open source?
CAD.
CAD, that's a good one. In fact, there's probably a dozen different CAD programs. Anything else? Any of you use something?
What? What'd you say?
Regarding software that would be
Right.
available on Linux or for open source, there's DVD players like VLC. There's a huge list. Almost anything that you would have used to have gone to a software store for is out there on the internet for the downloading. That somebody has written it. It may be freeware, it may be open source, it may be any of these licenses, but the point is it's shared to some degree or another, and its success is usually determined by how much it's shared. So there's software in most categories. Now the trap you've got to look out for is if you have used lots of things in Microsoft Excel, for instance, specific formulas, use tabs instead of the right controls, use spaces to move your things over, done things in ways that you effectively tricked the program to do what you wanted to do in your spreadsheet instead of doing it the way it was intended, then LibreOffice, when you try to open that same spreadsheet, ends up not looking right because it doesn't have the same flaws that the other one does. It has flaws too. I'm not saying it doesn't have any. But the point is they can't look the same because it's not the same program. Usually you can fix that by going back to the spreadsheet or the word processing document if you're talking like from Word to LibreWriter. You can take and fix the way it was intended to be done in the Microsoft tool, and now for the most part it will work in the open source tool. It's the exceptions, the human mistakes that don't carry across right for the most part. Now these pictures here, these are actually pictures, and also in the last slide, of various implementations that we've done in the real world of an appliance that we put together that I'll get to later. So now to the Internet of Things. What are the characteristics of the Internet of Things? Well, first of all, less expensive across the board. Plugins, parts, pieces, less expensive. And more responsibility on your part. Today's Internet of Things is like the hobbyist world of microcomputers in the 70s and 80s. You have to care enough to make it work, on the one hand, or you can buy an Apple with Apple's peripherals. Kind of similar to the way Scada is right now. Each company is still sort of an island. They're realizing they have to interact, but they haven't yet realized they can't be big enough kings. Google with their Nest, Amazon with their Echo. Huge, huge players. Lots of money at play. Also, unimaginable range of possibilities. Every human being has another unique idea for how something could be implemented if they had tools they may not even realize they have yet. That's the potential behind the Internet of Things. Just like with the IBM PC, it wasn't Windows that really gave the user the power behind what you could do with a PC. Rather, it was open source, which turned to Linux. Okay? It is never the proprietary that gives the potential. The proprietary is usually among the early to do what catches your attention because they pay for promotion and do something because they had an idea and capitalize on that. But it's usually focused in a specific area. Open source, the Internet of Things, PLCs originally, as they developed, they were not focused on specific areas. They were tools that those who had fun playing with them could do whatever they imagined to do. And the imaginations, you're just seeing more and more imaginations plugging together just like Lego blocks. So often the sensors are more capable than what you get with, say, a 4 to 20 milliamp. They could have more resolution. If they have the right protocols to talk to the brain, they could convey more information. One sensor can give temperature and humidity instead of just temperature. You can have a digital communication where you can have many sensors on the same wire, on the same loop. The economies of scale are much larger because they're cheaper, more people want them, use them, which means they're getting even cheaper to manufacture. The same reason smartphones can be given away with phone contracts at reasonable prices because the technology has gotten mature enough. The open source, the openness is always that which carries it forward. Connectivity and pluggability with auto detection. One of the big issues has been users technical capability to hook a 4 to 20 milliamp sensor to this PLC. What interface do you have to use? Oh, by the way, it's got to be a UL panel. We've got to have an electrician. We've got to have an engineer. We've got to have a... So it's a big project to do something in a larger industrial setting. But in the home setting, that's not so much the case. A home hobbyist can grab whatever stimulates his imagination, have it put in. Eventually, she realizes that there are things it could do that it doesn't do, and so maybe their kids get some maker technology, grab that, and do that thing. Got an employee who has a son doing school project with a moisture sensor and an Arduino, so she stops killing her plants by not watering them. Alert goes off if the soil gets too dry. They thought of that themselves. The tools are there to do it. The tools to do virtually anything exists in the makerspace. You've seen drones, you've seen robots, you've seen all sorts of things kids are playing, 3D printers. Yeah, it's not ready for industrial use yet, I guarantee you. But we didn't have the smartphone in the 90s either. But what was being done in the 90s prepared us for having the smartphone now. You've always got to be looking ahead at what's going to happen. None of these things are going to last 30 years, but they're Legos. So you don't have to redo your whole organization when something you can't get a replacement for. You find something equivalent and plug in another Lego block. You're happy. Okay? And the system stays the same. So connectivity, pluggability, auto detection. Your data, it can display on any browser, mobile or desktop screen. It allows configuration options to change the device behavior. Typically, in the older world, the device you bought did only what that device did, and that was it. Usually for a fairly high price, and it was very solid. I mean, you couldn't break the thing in most cases. But what it did was all it did, and a bunch of them are expensive. So far, things like Monet and Sensiphone and so forth, many other lower end brands, all they're for really is monitoring and learning, because it would be a legal issue if somebody used it for a critical life safety delivery, use a lot of money, lose a lot of money if water pipe breaks, whatever. So they've stayed on the monitoring and learning side. Another thing about monitoring and learning, you can have that in the cloud. Amazon can have a cloud sensor infrastructure. But with a cloud sensor infrastructure, if you're wanting that data for the flow rate to determine whether a valve needs to open or shut, you can't have that turn around to the cloud. What's more, if the communication breaks, then what? You've got to have local brain. Well, that's where we come right back around to the PLC, don't we? So, the Internet of Things is still mostly hobby and home consumer oriented. And that's kind of what it looks like. There's the Earth, there's the Internet, and who knows? All kinds of things all over the place. The world's getting connected. And guess what? Security's going to be a nightmare. If, in the new standards, that isn't paid attention to. But that nightmare will also be solved over time because so many people care. Brand operability is still an issue, but this is Legos versus guaranteed lifetimes. If you can, for less money, get a better whatever it is 2 years later, and it plugs right in and does the same job, why would you not want to? Especially if the system still continues to work exactly like it did. That's the promise of the Internet of Things. And I'd say it's coming on strong. I would not say it's here. The industrial Internet of Things is where it comes together. This is a next generation of the Internet of Things where interactive and programmatic control takes hold, where you have all the advanced tools that the kids are using. You have them in an easier to use way. There's interfaces that do drag and drop, has the components that you're interested in. They become as easy to use as your smartphones, instead of needing an entire staff to manage effectively the plant. Now, the operators are retiring and dying off faster than they're being trained. Without this, the United States infrastructure is in trouble. Fortunately, there is this. Technology has saved the United States and what we are in the world numerous times since we rose to prominence during the wars. We're about to do it again. This time, we're sharing it with the world in a better way because it's open source and other people in other countries can do with it as they will. So we have smarter devices and sensors of all kinds, mostly wireless, but wired is okay too. In fact, wired is by default more secure. It also takes more labor. It may take licenses to do. So a lot of the monitoring is done by wireless. The control typically is best done wired. It's got substantially better security than either Internet of Things and definitely better than the old Scada. It's starting to intercommunicate across vendor lines. Johnson Controls, Siemens, and Honeywell are all contributing to 2 separate projects at the Linux Foundation as to sensors intercommunicating both with each other and with their own PLC technology, SCADA technology, Internet of Things technologies that they're working on. This is not a one company thing. This is a whole world revolution going on here. In those 2 groups, the All-Join Alliance, the All-Scene Alliance, and IoTivity, I think, are the 2 device standards. If you've heard of Modbus, in the SCADA world, Modbus is kind of the standard for digital communication. The labor and training it takes to configure a system with Modbus devices is fairly extensive. This is a lot more sophisticated with self-configuring. It's a lot more like modern USB is, where devices actually contain their own drivers and the information about them, and which means the main brain discovers the device, which means you can put it together. You don't have to hire an engineer. And it's not just the same wiring type of protocol, but all of the various protocols and so forth making sense to each other via translators. So you can connect to the old and integrate the new. You can collect and archive massive amounts of data from which you can derive intelligence, which optimizes maintenance cycles and processes to save energy, save resources. Now, have you all heard that there's a new title that people are pushing, a new job position that ought to exist, utility manager? Anyone heard of the need for a position, utility manager? The belief is that almost all industry players are wasting up to 30% of the energy that they purchase. Tremendous amount of savings if you can save that. The utilities officer's job would be to monitor A, are we buying it from the source that's best for us? B, how are we using it? C, are the things out there using it efficient enough? D, where is there waste in the system, etc., and cleaning it up. And 30% of one's energy, I don't know if you guys have a clue what the power bill is for someone like AWWMA, just here in town, or larger. you're talking saving millions of dollars with a position whose purpose is to check on the efficiencies. These technologies make that possible in a way it's never been before. So from that data, you can then derive intelligence, which lets you detect where is that pump pumping against a closed valve. Do we really need to have the pump running right now? Should the valve be closed? Two good questions. Should we have a VFD on that pump motor? Is it going to save the price of the VFD in a short enough period of time? Those are the kinds of things that this allows. So you can end up optimizing maintenance cycles and processes. You can hook your data into your CMMS, your maintenance management system that basically keeps track of what are the maintenance cycles for all the equipment that you own. And instead of going out and maintaining it on some manufacturer's schedule, you maintain it based on the feedback you get from the device itself as to what's going on. Oh, that pump is vibrating a little more than it should. Let's see if it's three-phase pump. Let's see if one of the windings is burning out. Going to get really efficient when windings are burning out. Let's see. So this goes a lot further. The tech that not only do you not need to send tech necessarily out in the field to find out that there's something going wrong, but when the tech goes out, he already knows what's going wrong, may know what parts to take him, and has the manuals at his fingertips. Because that's all included as a part of the information that you're tracking. How do you do all this? Analytics. It's a cycle. You learn, improve, and more. Rinse and repeat. So you collect the data, you learn from it, you improve your collection of data, you improve the learning, and you keep repeating. Now each time you go around the loop, the gains are less than the gains were before. It only takes one round of gains to more than pay in many times for the system that's deployed. I loved the session before this one. How many of you managed to catch the session before this one? He was talking about how having sensors on fire plugs in a city that stay there and listen to noise in the pipes and correlate based on where leaks may be and how big they are. And as they reach thresholds with a particular leak, that goes back to the Scada system, which gets brought to their attention, and they go dig it because they know exactly where it is because the correlation is being done full time. That ties into this concept very, very well. Those sensors are a lot cheaper than stabbing in the dark or hiring a really skilled leak detection company to come find you the wrong place once or twice before they find the right place. It's not an exact science, but you can get really, really good with it. The uses of this stuff is almost unimaginable how far you can go with it. Then you go into data mining techniques, modern big style analytics. Here's an example. How many of you have bought something on Amazon? How many of you have bought something that Amazon suggested because you bought something on Amazon? That's big data at work right there. That is the good side of the collecting of personal information. The bad side, of course, is trying to steal your identity and, get whatever they can from you. But the good side of it is, and this is 99.99% use of the data collection, is how to make your things more convenient for you, how to give you more of what you want, how to predict what you're going to want. Or, in your case, how to predict what might go wrong with your system next, how to predict that this is you have usage and you have potential leakage. Well, the usage is fine. People are paying for that. The leakage is not so fine. That's waste and loss. So, the analogy. In everything. History may not repeat, but it certainly rhymes. If you can identify analogous puzzle pieces from similar past situations, you can predict the future with some level of confidence. That applies both to what I've been talking about so far and to how it applies to your systems and to you deciding what's going to go on in technology, or to somebody like myself who's been doing this all my life, that is the mechanism that I use to predict the future. People don't believe it's possible, but it is possible with about the same accuracy as predicting the weather. So, 70s and 80s mainframes, minis, IBM, DEX, Sperry, Univac, Burrow, and other systems, and the professionals who ran those systems. The majority of them who did not see in the 80s and 90s PC architecture, Ethernet, Internet, hobbyists, and open source. What happened? Anybody care to speak up about what happened?
Companies failed.
Yeah, the only one that still exists of these companies is IBM. And why does IBM still exist?
Because Gates came from IBM. He produced Windows 3.1.
Wrong. Sorry. It seems like a good answer, and it's the one Microsoft wants the world to believe. That is why IBM's baby almost destroyed IBM. Because they handed the keys to the kingdom to Bill Gates. The reason IBM still exists today is because they made a $6 billion bet on Linux in about '97. Big news at the time. So instead of trying to build and maintain several different operating systems side by side, they realized we're in the hardware business. We do hardware well. We need an operating system no one else can control, and if they don't, it doesn't matter that we do. So they saw the bigger pie issue, went back to creating the best hardware and adapted Linux into everything they did, and in turn took Gates' keys back out of their hands. So that's the same thing that's happening right now with established PLC and SCADA players versus the modern IoT. This is the rhyming battle. What can happen is these players, the big names that you know now, can either do like IBM did, or they can do like the others did. It's entirely their choice. So, I'm about ready to move into a little more commercial segment, show you some real solutions, and I need permission to do this. This has to be something that you guys want, okay? We can go straight into just discussing what's been talked about so far, or I can show you some real solutions that have been implemented. And these solutions are available, are possible at one level or another by probably any of the players that are out there right now. The only real question is, how much is it going to cost you and how complicated is it going to be? Anybody want to not proceed? Let's go the other way. Anybody want to proceed? Okay, that's an overwhelming majority. Thank you. My company, I'm the founder, is Intelligent Automation Alerts and Analytics. The reason we chose that name is that's what it's all about, right? Amazingly, nobody had taken it yet. And that is acubed.io. But in a domain name, you can't have a cubed, so it's ie3.io. Kind of a neat thing. I want to show you an example of one imagined use for this technology via a 3-minute video our team made to stimulate thought for the later discussion. Also, for showing to our potential customers to get them thinking about what kinds of things they might like. This is not about water systems. This is about automation in general and what the overview can look like. It's not aimed at any particular market. Then I'm going to show you a dashboard that's been done for Oral Roberts University that they literally watch the power usage for the heating and cooling in all of their buildings. This dashboard is used to control, but it is used to monitor, so their techs and their other systems then are controlled by that information. Then I want to introduce Northern Utility Services Central Dashboard, which can do both separate viewing of each of the systems they have out in the field, each of the water systems they have out in the field, or combined viewing if so desired. Dave will then give you some real life examples. Then we're going to go into the more group aspect. We're going to use our imaginations. How else these things could apply to water or wastewater or anything else in your lives that you think they might apply to. Other areas, and then somewhere in there I'm hoping people ask me questions about smart contracts, machine-to-machine micropayments, blockchain, Bitcoin, that sort of thing, because it all ties together. Okay. Whoops. Do I have volume? It's not you. It's not you. Thank you, though. I turned it down because it was dinging and beeping while I was working on it. I didn't want the prior people to have to listen to that.
The speaker's not on now.
Did you? Okay. We'll check that as soon as I get to. What I'm trying to do is get Windows to pop up the control bar at the bottom here. There we go. And you notice, as much as I love open source, I'm still using Windows on my own machine. It's really about the right tool for the particular job. And in my case, I just haven't had time to adapt this. And now look, this is Windows 10. My corner over here, so to make the screen bigger, isn't there anymore.
Double click the top bar.
Double click the top bar?
Yeah. The top, very top, there you go.
Very good, thank you, Aldo. Aldo is our software engineer. So, well, I just did it again.
Yeah, it works both ways.
Yeah, okay. Now I go to this one, and now I should have sound. Okay, I'm only on my computer right now, which means I'm not plugged in. I need this cable. Okay, this will either work or it won't. We got one more thing. Let's try that. There you go. We got sound. All right. Now I'm going to go back to the beginning. This is only 3 minutes long.
Meet Joe. Joe is a busy entrepreneur making some pretty high quality stuff. Joe's company is ABC Incorporated, a small business making things happen. Everything's going great, but one day, what happened? Despite all the expensive automation, he can't get the data to figure out what happened and doesn't know how to keep it from happening again. Joe hears about IA3 and their subscription service. Industrial automation and data analytics at home security prices? Joe is stunned by what comes with his IA3 subscription. Now in his facility is a simple appliance called IA3 Local. It connects to all of his legacy equipment, like his aging PLC controller, his heating and air conditioning system, security camera, which doubles as a quality control record, connecting wirelessly to the alarm system. Eventually, Joe's old PLC controller fails, so he has his IA3 dealer program the appliance to take over. Joe soon realizes the power of this new generation tool. With IA3, he's got real-time and historical data, which can pinpoint problems and prevent future catastrophes, receive alarms and alerts as appropriate, and allows Joe to optimize his processes. Now this is what the Internet of Things is about. Real automation. The IA3 appliance client synchronizes its data to the cloud, which in turn provides global secure access to Joe's facility data, controls, as well as advanced analytics. Joe is amazed that he can access the IA3 interface wirelessly either in his facility or securely anywhere in the world. Freedom at last! Joe runs things from Hawaii, and even some employees can take time off. Joe is speeding past his competitors because he has vital intelligence. Joe now has both a growing family and a growing business, and ABC Incorporated is booming fast. In fact, yet again, he leapfrogs ahead of his competition by building a data-driven fleet from the ground up to deliver product to his market directly. Joe doesn't have to worry about power outages or even loss of connectivity to the cloud because data is archived both up there and on site. Joe's employees love IA3. The interface gives them real power to find problems and keep them from happening, monitor functions while performing other tasks, and find new and exciting ways to grow ABC Incorporated. Joe now knows that the power of data is intelligence, and with IA3 continually enhancing its appliance and interface, Joe's subscription keeps providing more and more value. Joe and his employees don't care about the hardware. That's just an incredibly powerful black box, but they love what the information enables them to do. Data and knowledge lead to efficiencies, and efficiencies translate to opportunities and profits. Joe likes profits. Joe will never forget the day IA3 changed his life when he asked himself, can I really get industrial automation and analytics at home security prices? And now Joe knows for sure that we all can. We call it automating the real world.
I don't think we necessarily need to hear about the Rubik's Cube. Anybody like that?
Good.
All right, thanks.
Scrambled cube.
Yeah, let's not scramble the cube.
Okay.
All right, so here is the ORU dashboard. This is the total usage for energy literally at the ORU campus. And then there's a map here, and there are various buildings. And here's, again, more overall. And then you can see here the main meter, virtual meter, central plant, each of the different buildings, etc. So there's more of that. There's also graphs and charts that you can do. Or on the map, you can pick a building and then see the stats for that particular building. Multi-site. Okay? This tells you what it is. This here tells you, you can click for the electricity, the cost of it, greenhouse gas equivalent, electricity per square foot, for today, over a month, or over a year. You can also see via the history, statistics via bar graph, and that's just for that building. And I can click back and forth to any of the buildings that way. And they actually have dashboards mounted with tablets in every one of those buildings, so people walking in and out can take a glance at it and basically get a feel for what's going on here, the world that they live in. It's really pretty cool. That's one of the implementations we did. Another one, this one is, and I did it again. I keep, my screen here isn't as big as it should be because the projector dimensions are different. So this here is what we call our office server. And the office server, this is the stats right this moment, right up through this time at Valley View. Right this second, they're using 20.3 gallons per minute. The tank level, which is an outside tank, is now at 19.9 feet. Total usage since we've been monitoring it is that many gallons. That's the system pressure currently. That's the humidity. The door is closed and nobody's been there since March 21st. And when it was when this last changed was at 11:35 a.m. and the keypad is locked, which means, well, it's locked. If somebody goes to open the door without unlocking the keypad, there's a security alert. Okay? This is not a security system, but there's no reason it can't do security functions. It tells us what the status pumps are. The well pump is running right now. Booster pump 1 is off, booster pump 2, etc., etc. Well, we can, that is a configuration screen, I always move the mouse there. We can look at a number of different systems. For instance, this is a simpler system we didn't decide to monitor as much at. That's Alpat. This one is one that is nearly complete. It's actually running and making water. Yeah, not at this exact moment. Dave's still babysitting it to completion. This is the demo system that's actually on the desk upstairs, and the information is current. You'll see 935 here is the most recent piece of data, and the reason is these are all by default cellular. That doesn't mean we can't use other communications methods where that's the better way to go, but cellular, for the most part, makes the most sense because you can take the device anywhere, anytime, do anything with it. So as you can see, there's a list of things here. Potter Creek, this is their reservoir, etc. We've got, there's a quick story I'm going to tell you about Sherwood. This is an example of how this is useful to you. Memorial Day weekend, Friday afternoon. Our Wasilla Tech calls and says, hey, I'm going on my fishing trip like I was planning. Anything I need to pay attention to before I go?
Mark, I was going to get into that part in detail.
You want me to let you tell it?
Yeah, I can get into that.
All right, well, I'll let you tell it then. All right, you want me to not tell any stories about this and just go do your thing?
I can explain.
Well, why don't you come take the spot then?
All right.
I'll show you real quick what the status is. We didn't have it because we didn't have an opportunity to sync up first. Okay, this tab here, the card.
Okay.
This tab is that exactly.
Yeah. Well,
This tab
I'll let
is
you-
that.
I'll let you.
No, I'm gonna let you run it.
Okay.
And then this tab is that. So when you move between cases, use a different tab. For now, just use this tab.
Okay. So, my name is Dave Kranich. I'm Northern Utility Services, and my company operates and maintains almost 60 community water systems in Anchorage, Wasilla, and down the Kenai. And they range in complexity from real simple, just a well and pressure switch, to we've got a surface water treatment system, a large arsenic removal system, and a couple other more simple ones. This Sherwood Estates is a system that is awaiting funding. So everything that entails means that we're running it on a shoestring until we can try not to put any more money into it than we have to, and saving our effort for when we can do the major renovation. So so this system has had issues, and we're working on it, and so we have to have a fair amount of oversight to it. So on March 20th this year, we've got a reservoir there. It's got an 8,000 gallon reservoir, and it's got an alarm level set at 4 feet. It's an 8-foot diameter tank. So so I get an alarm on March 20th. Let's see. Did you set the time on that?
Yes, all these tabs have the times you asked for set, so you can take it right from where it's at.
Oh, I see. Okay. Here.
Do stand this way more because the camera doesn't go quite to where you are right now.
So I get the alarm, and so I pull up my phone, and I can go and take a look at this this trend here from.
Could you join me over here? The camera picks you up over here, right where you are. It does not.
Oh, I see. Oh, okay. Sorry. I wasn't listening to you. Sorry. So the data up here that's normal operation. There's an iron removal treatment system at this. It got pretty high iron and manganese. So the comes up, shuts off, and and then filters more water, and this is normal operation. And all of a sudden, we've got this thing going here. And of course, I'm trying to make a decision whether I want to drive an hour out to this site or not. And so then I go to some more data, because this isn't enough data. All this tells me is that things are going bad fast, right? And I've got the levels set, so the alarm set, so I've got some time to be able to decide what the problem is. I've got time to get out there before they run out of water. So I go and I pull up a number of other parameters.
Scroll down.
Yeah. As well, to be able to see if I can get some, no, this is not what I was looking for, Mark.
That is the second item on your.
Yeah, okay, well, I'm just gonna go to the data, right? And so, so I want, I'll have to navigate to that date. But, I wanna look, on that day, I wanted to look at a number of different parameters. So I wanted to see chlorine level.
It's easier if you look at this computer screen.
I don't know, it's easier for me. So,
Okay.
I wanted to look at the tank level. I wanted a flow meter, see what was happening at our flow meter. I wanted to see backwash filter state, and then just for grins, door contact. Okay, so then I'm going to go down and I'm going to navigate to that day back in March. Of course, I wouldn't have to do that on the day in question.
Dave, you want to change the year?
No, this was this year.
Oh, okay.
You need to hit the button to make it graph. There you
Do this to me.
go. It'll play the moment. Don't worry about it.
There's not much of a time range in there.
Oh, that's the problem. Sorry. That's right.
Don't get
Yeah,
too much of a hurry if you're clicking.
Yeah. Okay. Okay. So there we are. So now I can see correlations between my data, and I can begin to look and see, do I need to make a trip out there or not? So blue here is my flow rate, and sure enough, I've got an increase in flow, but I started going out of my normal operation when the flow was down here at minimal flows. So that tells me there is a problem. Now, what also tells me is that my backwash was triggered right then when that all started. So that tells me that my backwash valve, which has been kind of flaky historically, it has stuck in the backwash condition, and it's running my tank out into the settling pond. So yes, I got out there, and over here, the green door contact, that's when I showed up. So there we go. So
So they never ran out of water.
so they never ran out of water, but we were able to go out there and get things, and here it tried to trigger another backwash cycle, but it was malfunctioning. So
They would have run out of water if you
That's
hadn't
right.
made the run.
so let's take a look at another
Now go to the other tab. That's your other one. This is set up with the first data point with what you
Okay.
asked for the range.
Okay, so let's see. So we've got this isn't where I was.
Okay.
I wanted tank level. So that's okay. So let's see. So we've got 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 49 50 51 52 53 54 55 56 57 58 59 60 61 62 63 64 65 66 67 68 69 70 71 72 73 74 75 76 77 78 79 80 81 82 83 84 85 86 87 88 89 90 91 92 93 94 95 96 97 98 99 100 101 102 103 104 105 106 107 108 109 110 111 112 113 114 115 116 117 118 119 120 121 122 123 124 125 126 127 128 129 130 131 132 133 134 135 136 137 138 139 140 141 142 143 144 145 146 147 148 149 so here we had our tank level, and guess what day this was? Saturday. And so I get my, and then of course, excuse me, this is Friday, this is Saturday, and I get my alarm here, it just barely triggers my alarm. And this is middle of May, and so I'm able to open this up, and here I'm thinking the same thing, you know, previously. Do I need to jump in the truck and go out there? So by then going and pulling up my flow meter, and let's see, filter state, backwash state, let's see, go to contact. Now I can pull that up and I can see, okay, so what's going on? Well, boy, I've got, now this meter that we're looking at is, it's a strap-on ultrasonic meter. Remember, we're saving bucks, and it's not what we'd like to have ultimately, and the placement was kind of suspect for turbulence and that kind of thing, so it's kind of just an indicator only. It's not particularly calibrated, so we've got, at our peak, we've got more than 8 gallons a minute going out here, but relative to when there's very little flow, it gives me a good idea as to a relative indication of what's going on in the plant. So I can see we've got this, our tank level is dropping and our usage has gone way up. And we can see those backwash cycles happening, and the backwash cycles, it started dropping before the backwash started cycling. It was working fine before. It's recovered after the backwash cycle here. So I can tell that there isn't a problem there. But there is what does appear to be happening, and in this case, I haven't wanted to spend the money on a meter on the inlet to the filters. So which would be a great piece of information, because maybe the filters are plugged. Right? But looking at this data, I can begin to see that, you know, it looks to me like it's not recovering as fast as it has before. Even with this kind of usage, I can go back previous, and so I was able to derive that, you know, I probably better run out there. And so you'll see a bunch of backwashes happening right here, and I don't know, that green is in there somewhere, but it must be just kind of covered up.
Yeah.
So there's a door contact in there, opening in there, and so Sunday evening, I went out there and did some backwashes, and then we got a little better flow going through it, and we were able to recover. And it turns out this was a really dry weekend, and everybody, you know, it was kind of the beginning. Everybody was out gardening and watering the lawn and all that kind of thing, and so our production just wasn't keeping up with demand. But I was able to not go out there on Saturday because I could look and I could see that, yep, everything is functioning, and I could monitor, and then it started coming back up, and I said, okay, it's just usage. So that's another scenario here, and then I just discovered something. I was in preparation for this last night. You know, it's good to be able to every so often go and look at long-term trends, and I've done this on a number of different systems. In this particular one, I hadn't done it in quite a while, and I looked at the flow rate for the flow data for a whole year on this one system. It's here in South Anchorage. And I discovered, and I've zoomed in on the data here, I discovered this interesting section where I've got flow down at this range here, And then, but I've got this section here where
Average flow is higher.
average flow is quite a bit, is significantly higher. And, does anybody have any idea what's going on with that?
Leak.
Well, I'll tell you, the first clue here is we fixed a major leak right here. And then we flushed the system out. So what do you suppose this over here is?
The leak started.
That's when the leak started, yeah, that's right. And I went back through the work orders on the service on that system and discovered that, well, that's on that day, we did a hydrant flow test for a client, for a property owner that wanted to know what the hydrant flow was at the hydrant next to his property. His insurance was looking for that. And so apparently that hydrant got closed a little bit faster than it should have been over here. When we fixed that leak, that pipe was in pretty bad shape. So I'm not gonna throw the book at the guys that did the hydrant flow test.
So
But-
the old valve failed?
Right. No, it's not. No, it's the main line was corroded and blew out a big old chunk out of the side of it. But anyway, so we did not have alarm points set, and this is one of the things where we want to go with this product is begin to do some trend analysis, which would have showed me over here that my minimum trend, that my minimum flow was out of trend. So, and since this system happens to be buying water from AWWMA and reselling it, this period right here represents about $8,000. So, anyways, that's what data can do for you, though. And since we have had this kind of data and the ability to be able to compare one data stream to another and go back and look at, I can go back and when I've got a problem and I'm trying to figure out what's actually happened, I can go back to, well, I seem to remember we had this kind of a problem back a couple months ago. I can go start fishing through the data and I can see what happened back then and begin to divine what actually is happening. Turbidity measurements, chlorine residuals, all kinds of things interact with all the other things, your pressures, your flows, your all the parameters. And so when your pump cycle and filter cycle, valve cycle, whatever, and so when you can overlay all that data and be able to examine that data, there's real power there for you. So that's what this system has given us the ability to do with the water systems that we're responsible for. So
This is another one of his water systems. You want to talk about it, or you want me to let me talk about it?
oh, you can talk about it.
Okay. This was a system for a trailer park called Southwood Manor that has about 1,200 residents. And they were considering buying water from AWWMA, and they figured out how much that was going to cost over a 5-year period and decided it was better to create a treatment plant for the arsenic and iron that they had in their water. And that was the reason that was forcing them to AWWMA, was the arsenic rules having changed. And there was a cycle behind that I don't necessarily know. But this, in effect, is kind of their dashboard with the gauges of basically what's going on. The tanks, levels, pumps are automated. And here is what Dave's father, the engineer, uses to analyze what's going on. And it's the same kind of graphs as Dave just showed you, except here, where I hover over it, it shows me what is it and what the level of it is as I go across. And so it's quite a bit more convenient. We're in the process of changing the one set of software to have these capabilities. This is a fairly expensive option, but it is available. But here you can have any time frame and map the major trends against one another. So this is the other interface that we currently have.
And just for the record, you can have it on your remote devices, your phone, tablet, whatever you have. It's same information, same everything. You don't have to actually be physically at the plant to see what's going on and get the information. You get a phone call saying something's happening, you can see what is happening right here.
So I'm going to put this back in present mode here, and we're going to leave this slide on the screen. This is conversation time. We've zapped through pretty much what I wanted to zap through. Are there questions or insights that any of you would like to share? I encourage speaking up. That includes either the people that are directly involved with us, Aldo, Kai, and Dave. Would you please stand up and identify yourselves? They're actually, Kai's our general manager, Aldo is our main software engineer. Dave actually owns the company that needed this tool and couldn't find it at a price that it could be afforded, and brought me up from the States to build this about 4 years ago. And since then it's continued getting more and more sophisticated. And recently they decided that this was a technology that should be spun off and made available to anyone and everyone, and that we ought to go to different industries, etc. So our business plans between Northern Utility Services and a division of Northern Utility Services started to diverge. And so we've been spun out as IE3. And that's how we're sort of together and sort of not together. And I feel like things like that need to be revealed. They can't be mysteries.
He used to be our boss, now he's our customer, which makes him our boss.
Yes?
You mentioned that Mongoose has been the standard, but it's now being replaced by a couple of tools. One was called All Scene Alliance, and the other was, I couldn't catch the name of the other one.
The All Scene Alliance makes something called AllJoin, which is a protocol under development. It's housed under the Linux Foundation. If you go to linuxfoundation.org, you can find it there. There are very, very few devices that use it yet, but that is going to come on big. Another one is a protocol called IoTivity. It's like activity, except it's IoT instead of the A.
Also at the Linux Foundation?
That is also under the Linux Foundation. There are two competing entities, two competing nonprofit groups, both cooperating on the Linux Foundation while developing themselves what they have different, sharing code for what they have the same. This is what the future, in my opinion, looks like. I think that's what the next generation, which is fed up with being fed BS, and can now tell when the media is telling them the truth or not based on friends they have in countries where the news claims such and such is going on, and it's really an entirely different story. Our next generation is becoming very aware because of the internet. And IoT is simply taking the internet and computing to the next level of interacting with the world on your behalf. And those two projects, I think, are very important over the next probably 10 years. I don't think you'll see major use of them for probably 4 to 5 years. Any other questions, input?
So, this water plant, you showed a couple of water plants. Typical install cost?
We have two components. We do a install cost, which we continue to own the appliance. IE3 basically has a subscription service, and we continue monitoring the cloud aspect of it, that you have connectivity, that all the components are working well. If there's an upgrade needed, we don't want to have to go to contractual issues to do the upgrade of the device, the repair of the device. So the central brain, the appliance that you saw in the Joe video, we basically provide on a subscription service. The sensors, we try to adapt to whatever sensors you already have. insert ourselves in whatever digital loops, circuit loops, or 4 to 20s you already have. If you don't already have specific sensors, we have a set of sensors that we've proven over time. And in any case, you buy the sensors and you pay for the install hours. The subscriptions themselves depend on the scale. Yes, Dave?
Yeah, so I can address that. So that system had, when we got involved in that in 2003, there was nothing there. And
Specify which system.
That's Sherwood State.
Okay.
So at that point in time, we had bought a sensiphone unit, and we had installed a meter that could be read by that, and a tank level sensor. And so we ran that system. There was a guy out there that lived out there that checked on it every day, and that's how that system ran for quite a while. About a year ago, about 2 years ago, we installed a chlorine sensor there because they were always chasing the chlorine, and then the guy that had been watching it wasn't available anymore. So we installed this system to be able to monitor it remotely. And so with the combination of the point analyzer and then we added that other flow meter, then we were able to get basically the data that you see there. So about, what was it, I guess between the analyzer and the flow meter, about $3,500, $4,000, and then the actual install of this, I think we've got on the books $7,000 total. So in the install, and then the subscription for this site, I think is $200, $250, something like that, if I remember correctly. Which may change since I'm not the boss anymore.
And remember, these are just installing sensors,
Yeah.
so somebody's going to be installing somewhat sensors. If you've already got sensors, we'll just listen to them.
Yeah, and so the other one, that Southwood Manor system, that was a package plant that came with a PLC.
It's an Allen Bradley,
Right.
and our box became the master, in effect, to that Allen Bradley that retrieves data from it and
Right.
makes it available to the world at a cheaper price than, let me scroll back. Where's the clicker? There it is. This actually is the Allen Bradley at Southwood right there. And this box on top that I showed earlier, that's a standard UPS that was bought for a computer that was there before that we're using to extend the battery time that's a natural part of our appliance, which is this part of the black box right here. That's all the appliance that's there.
Well,
And it is cheaper. The whole thing price was far less money than this panel in this box by itself.
So in that case, we're riding across on the top of the system that was already, a PLC there, and we're just taking data off of it, and then we've added a couple other sensors since then to get a little bit better data that the package plant had not given us from the get-go.
And we installed control for the
Right.
tank
That's right,
level.
and so a lot of
Controlling
you have
VFD.
say VFDs have become pretty popular. A good number of them we like to use ABB drives, and they have Modbus capability, so we can read we can read hertz and pressure, system whatever pressure and
set points.
off, and actually change those set points remotely through the system just by connecting up to that. So that connection is a pretty simple connection. So.
But going back to the original question, that Southwood system, when that got added onto the Allen Bradley PLC, there was practically no real install. It was an Ethernet connection, and we were done. So if you've got an existing system that all you need is the logging and smarts and whatnot, that aspect of it is negligible.
Another system is Oasis, and Dave has actually presented the story of how that system came about a number of times. Many of you may have already heard it, but this is the original box that our box went into out there when it was still a well out in the field. Then this well house later was built, and the components were taken out of this box and put over here inside that building. So these are the two VFDs that run that system. If the Rosemont guys are in here, I talked to them last night and they said the Rosemont's a great analyzer. Well, we just happen to have one sitting here right beside our box. Those VFDs, these happen to be ABBs. We found they do real good Modbus communications. It doesn't have to be an ABB. We just have more experience with those than we do with others. But they do need to be able to talk digitally. They don't have to be Ethernet necessarily. They can be RS-45, but they do need to be able to talk digitally, Modbus at a minimum. And that's the biggest thing when new systems get designed and you're trying to save money. Make absolutely certain anything that you replace is capable of a common digital communication. Because even if you don't want to do that communication right now, it's not going to be long before you do.
On that note, I'm a project manager for a lot of capital projects that we want to try and start integrating this in. How would you specify that, or how would you review a proposal and know that that's, do I look for open source, or what's the how would you make sure that you've got something that's the Lego and not the
Well, you picked up on the right point. The first thing is what protocols do the things you're choosing talk? That's probably the single most important thing. The second thing is, are they RS-45, are they Ethernet, or are they something else? Something else is unacceptable. It's got to be RS-45 or Ethernet, and Ethernet's probably preferred. There are other details that I can tell you that are going to be probably system and choice specific. That's where, like when you're designing a new building or something, you're going to want an engineer that has skills in that area to assist you with it. And that does not have to be us per se, but that is what we're creating a consulting arm, and that's what our consulting arm will do. We'll assist you with what kinds of definitions that you need. Doesn't necessarily mean you've got to have our system now, but it helps us also know what it is we're going to need to do if we can't do it already.
So along that line, there's kind of two different outlooks that a system might get designed around. One might be where I would say, for example, the HowPat system where we're monitoring the flows, and we've just got 5 sensors there. We want to monitor and make sure that the heater hasn't quit in the well house, and that the flow, be able to look at the trending on that flow. So in that case, we're just plugging 5 sensors directly into our box there. In a more complex system, you may have it oftentimes makes good sense to have a number of local brains on different processes. For example, your chlorine analyzer, a lot of the Rosemont upstairs and Geosigna, a number of them have devices that measure pH, temperature, and chlorine and the free chlorine residual. So those pH and temperature compensate the chlorine analyzer so that you actually get a compensated value out, and that's important for regulatory compliance and other things. So the idea that brain is there, that's great, but being able to talk to that thing in such a fashion that you can look and find out what the pH is, what the temperature is, and calibrate the thing online as well, and actually really be able to communicate with those. That's really what you're looking for. You don't want a device like that has a 4 to 20 output that all it does is tell you what the chlorine residual is, the end of that process. You want to have something where you can communicate to it and find out all the other things that it knows. Another example would be a turbidimeter. In some cases, you want to be able to have a closed loop, and those are systems that stand alone. So if your main brain has a problem, your plant is still running based on these individual processes. So your chlorine analyzer might be running closed loop with a chlorine feed pump. So that process will continue to run even if, you know, the main brain had a hiccup. But being able to get all the data that process is analyzing, has the capability to bring out. It saved our bacon in several cases, and that's the kind of thing that we're looking for long term, because as time goes on and that big data aspect of this really comes into play, where all those other parameters can get analyzed, it'll be really I'm quite convinced that it'll be very surprising to us what we learn by analyzing some of those data streams that nobody ever looks at.
One specific example, which I was starting on Sherwood that you actually didn't tell, was the one where the filter was clogging and the tech had gone out to on his Memorial Day fishing trip, and it was like an hour after you left that we realized there was a water pressure issue, and it didn't look like the system was going out, but the water was being used faster than it was being made into the tank. And as it turned out, the filter was clogging earlier than it should have been. And we guessed that. We didn't have differential pressure across it like we did at Oasis. Differential pressure across it would tell us, you know, that there's too many pounds of water going away there. But we were able to derive from the data that we did have that that's what was going on. And rather than drive out there, we realized we had the VFD connected, which I'd done on a lark actually. I hadn't even been asked to. And we raised its target pressure. So until Tuesday, it forced enough water across that filter. 10 more pounds of pressure let the Sherwood keep up. So instead of a weekend, well, not an entire weekend, but a goodly chunk of overtime, plus then you find out you don't have the spare filter anymore and can't get another one, in that weekend alone, the system more than paid for itself. And those are the kinds of examples you can pick up and the kinds of things you can't anticipate that talking to that VFD is necessarily going to be that valuable. But if you have it, it's there to think about it after the fact, and it can be used in ways you never imagined it was when you were going to when you put it in the first place.
So that's what resulted from the Modbus communication, being able to talk both ways with that and give commands to that VFD and tell it to raise its target pressure. So
what do you do for security on the ingoing commands?
Well, we have the local device, which is basically a Linux server that has full tilt Linux security on it with just our very specified channels through it that takes specific permission to be able to do in our secured channels. Those secured channels are only available from our cloud server, which in turn has its own protected from the world security. We've got several different layers, and we know that system is not likely to be a target. So on the off chance our cloud got hacked, and the off chance that the person were actually able to identify the remote system that talked to, they'd still have to break through the firewalls and the virtual private network to the remote system, and then they'd have to figure out what's there and whatever. Likelihood very, very small, but there is always some small percentage of potential penetration, and that's where the data diodes come in if you think that small percentage justifies it.
Where does the data diode get applied at?
If you have to ask, you don't need it.
Yeah.
Let me give you the short version. We've got layers of security, and we could bore you to tears, but it's secure. If there's somebody who needs, if there's somebody who needs to have that answered more specifically, I'm more than happy to go through the details. But we've addressed it, and we're.
Like a historian.
What's that?
It comes from basically like a historian.
Yeah. So anyway,
Not
we're.
the actual data, but the stored data.
Yeah.
Yeah, the data that you're looking at with the phone you're carrying out is the data on our cloud server. That's why you're paying the subscription. You're not looking at the local site. You'd have to do. You couldn't get to the local site unless we enabled it for you, and we'd argue with you for a while before we let you do it.
Okay. But like I said, we've addressed it, and if somebody cares enough to know how we addressed it, we're happy to explain it in technical detail, but short answer is it's reasonably secure.
And we're in the process of figuring out what kind of changes does our cloud need to be able to propagate out to the remote. And if anything you need to do goes beyond that, then we do it for you and maybe come up with another classification of something that needs to be able to go out. We very much limit what we deal with in the field. So one other quick thing I want to cover before I'm out of time. This smart contracts, machine-to-machine micropayment, maybe the blockchain. Credit cards doesn't sound like it really applies here. You use credit cards in restaurants or whatever. But the proof is you can't make small charges on credit cards, and banks are not set up for instant transfers. And in a water system, as an example, if you had a water meter that reports its gallons back to a server owned by the water system, and the customer is wanting to pay by the gallon, you can literally, with the blockchain, set up a payment situation where there's a smart contract, and automatically every gallon that goes into their system, a small payment that's equivalent to that gallon goes into the water system's account. Ergo, continually pay as you use. No waste, just direct connection. It's called machine-to-machine payments. And whenever the machines belong to different departments, anybody that's got a different accounting books that they're responsible to, this suddenly becomes useful. You can do it inter-department, you can do it inter-company, you can do it for electricity, you can do it for water, you can do it for songs. There's artists that have already released songs on the blockchain for pennies, but when you pay those pennies, you then have a microcent that song is attached to, and it's your song. You can play it anytime you want. You don't need Spotify, you don't need your internet connection, you don't need anything. And if you want to sell it to your brother, you can, whatever price he wants to give you, you can switch that token to your brother, and now your brother owns the song and you don't, kind of like the DVDs used to be. It potentially brings ownership back in a way that the current cloud strategy almost takes away. What's more, you can take, and actually with something called Ethereum, the cloud becomes a programmable entity on top of a blockchain, which means the computing, who knows where the computing is and who cares? The question is, does it do what you're wanting it to do? And I could go into blockchain and what it's good for hours. The most current example you've probably heard of is Bitcoin. And no, Bitcoin is not a scam. There have been a lot of scams around Bitcoin, just like there's a lot of scams around the dollar. But Bitcoin itself is not a scam. And the network has never been hacked. And there's almost as much money moving across Bitcoin worldwide as there is across PayPal. Kai, did I miss anything? Anything you'd like to see talked about? We have just a few more minutes.
No, I think it's been well covered. We've got as you said that down there, we've got a booth with one of the machines sitting there upstairs. If you're interested, come by to see it. And we'd love to find out more about opportunities that you have. This is really a work in process as we're developing this and expanding it beyond its original focus within US out to the broader area. So we're looking forward to learning more about applications and people who might be interested in this.
I'm a little curious, just a quick question. I'm an operator, it's Saturday. I can see the analytics, I can see all the stuff. I can make then changes to stuff if we're hooked in with that, with the VFGs and such?
If we set it up that way, yes.
Yeah. So, but I can do that. I don't need you to do that. I don't have to call you up on Sunday and say, hey man, well, look at my pump here, I need to turn it up.
There's two possible scenarios. Number one, NUS is in the business of contract operations, among other things.
Yeah.
And any service they have is available. You could contract with NUS for an operations contract, which is different from our automations contract, okay? Or you can be the person with your own console on our system, and then we needed to anticipate what kinds of control that you needed without being local and provide for those in advance.
Okay. And with that, I mean, I work with lots of different systems. I'm working with 4 different types of automation and 30 different systems right now.
We could combine all that.
Yeah, I don't even want to mess with all that yet.
Well, that's,
No, we don't.
Holes in all the dams at this point.
We don't. What I'm saying is we don't replace them.
Yeah.
We literally combine them in a common interface.
Yeah, but I was wondering, it's like I'm dealing with a lot of different people that need remote access to work, because I'm not the only one. You know, there's a whole slew of operators. I'm technical assistance for them. So that's something you can do. Like a lot of, you know.
I believe the answer is yes, and I think this is like her question. It's time to break it into a conversation between you and us about your specific case.
To throw something out there, I see all the time, you know, there's all kinds of different devices coming out here that have a mobile interface, and oh wow, that's really cool. But how many mobile interfaces do you want to be keeping track of? A password and a username and
an app,
and a data stream and an app and
then they don't talk to each other.
Yeah, and then they don't talk to each other. So you can't overlay this piece of information over that piece of information because they are related one way or the other. And so that's where we see a big opportunity for being able to take these really capable devices that have been proved out in the field, working just fine, and be able to bring the data from data streams from different manufacturers, different kinds of devices, all into one interface. That you know, that interface is going to get a little bit messy. You know, you're going to have a lot of different pieces of data that you have to poke through and figure out which ones you want to compare to. But the beauty of this system is that you can put together different watch lists. So I can have a watch list that has this set of parameters, so I don't have to go fishing through a big list to find them. I can look at those. I can have that set of key parameters that I can look at. I can select from those ones to just like I showed you there, and then so you can organize your facilities pretty complex, really. And then the level of then there's different levels of access to that data. So for my operators, no changes can be made. No levels can be made. They have a secure login.
Yeah.
But then if I want to get onto it, then I have my login and I can get on there and I can change the parameter if I want to.
I have what I hope is a cool analogy. The IBM PC was just another microcomputer out there so far as the public was concerned, other than it had an IBM name on it. What really, though, made microcomputers take off is probably VisiCalc. VisiCalc and WordStar. WordStar on a PC was the word processors, as VisiCalc was the accounting machines of the time, as our interface and what we're doing now is to the Scada of today. That is my opinion. Anything else? I think we're pretty well wrapped. Thank you very much. I appreciate your time, your interest, your input, your questions, your participation.